Assalamu alaikum everyone. I hope you're all doing well. Welcome to the 7th episode of Bridge the Gap. Today's lesson is basically linked with our 6th episode in which we talked about proportionalities, quantities being directly proportional and inversely proportional to one another. Today we'll be solving a few questions in which we will use the idea of those proportionalities. So let's begin. The first question that we have over here is that in order that a train can stop safely, it will always pass a signal showing a yellow light before it reaches a signal showing a red light. Drivers apply the brake at the yellow light, and this results in a uniform deceleration to stop exactly at the red light. So there is a train which is being stopped. The brakes are applied when the yellow light is seen and it stops at the red light. They say the distance between the red and the yellow light is x. What must be the minimum distance between the lights if the train speed is increased by 20% without changing the deceleration of the trains? Now, to solve this question, I have written an equation that we are supposed to use. Now, you guys are supposed to remember this equation when you will be in your A levels. Right now, because we are trying to bridge the gap, so I'm giving you the equation myself and I'm going to tell you what quantity represents what. This U is basically the initial speed. This A is acceleration, and this S is basically displacement. So they're asking what must be the minimum distance between the lights if the initial speed is increased by 20%. So looking at the statement, what I can see is that we are trying to relate two quantities, speed and the distance. While looking at this, I figured out that U square is directly proportional to S. So this is the proportionality that I'll be using to solve this entire question. But before going into this, I need to find out what is a 20% increase in speed. You can simply do maths over here. You can say that initial speed was zero at the start. So if I increase it by 20%, add 20% in it. So my new speed is going to be U plus 20% of U. 20% is 0.2. That is 20 upon 100. So it's 1.2 U. So my new speed is 1.2 times of U. Now I'm going to use the proportionality that I just extracted out of my equation. I can say that when the speed was U, and I'm going to place a square because U had a square over here, so I'm going to place a square over here as well. When the speed was U, the displacement it covered was x. It was given over here. If the initial speed is increased by 20%, that is, if the initial speed is now 1.2 U, again placing a square. Why? Because it was U square directly proportional to x. What will be the new displacement? I'll say it's going to be s. And then I'm going to cross multiply. So when I'm going to cross multiply these two things, they'll look somewhat like this. It's going to be U square into s equals 1.44 U square into x. U square cancelled out. S is equals to 1.44 of x. So we have our answer, that is C. We haven't used any complete equation. All we did was play with the proportionalities. We saw that based on the equation that was given to us, the speed and the displacement were directly proportional to one another, and it was U square being proportional to S. What we did, we first figured out what's going to be the new speed, because that is going to be our second variable. So we said that the initial speed was U, and if you increase it by 20%, we added 20% of that, so it became 1.2 U's. And then we applied the proportionality method. This was the key step in our question. This was the key step in our question. It helped us to figure out what's going to be the displacement if the initial speed was increased by 20%. So our displacement will increase by 1.44 times. Similarly, we have another question. It says that a diagram shows a laboratory experiment in which a feather falls from rest in a long evacuated vertical tube of length L. The feather takes time capital T to fall from the top to the bottom of the tube. How far will the feather have fallen from the top to of the tube in time 0.5 t? Now, the equation is given to us, and we'll see which two quantities are we going to relate. We see that over here we have a relationship with time of displacement. And these are the two quantities that are going to be important for us, because we're trying to find out the new displacement when the time is 0.5 times of t. So from this equation, I can see that displacement is directly proportional to t squared. Now I can use this proportionality in solving my question. So for example, if I say the distance was L and the time it took was capital T, that is to fall the entire length of the tube, which was the distance, the time it took was capital T. So if what distance will it travel if the time was only 0.5 times of t? What distance will it travel if the time was only 0.5 times of t? And remember, not to forget this square, because displacement was not proportional to time only, it was proportional to time squared. So do not forget to put a square on the time variable. Now you can cross multiply. It's going to be like length times 0.5 t whole squared, x times t squared. This is going to be 0.25 t square. T square cancelled out. X is equals to 0.25 of L. So we have our answer 0.25 of L. So you see what we did? We, based on the equation that was given to us, we just saw the two quantities that were being related. We extracted them out and we saw the proportionality in them. And then we applied the basic proportionality method, that if two quantities are directly proportional, write them like this and cross multiply. Just don't forget if there is power on any of the variables, because if you're going to forget that, you'll definitely get a wrong answer. Now, let's solve one more question. The question says that the acceleration of free fall on the moon is 1/6 of that of Earth. Gravity on the moon is 6 times weaker than that on Earth. On Earth, it takes a time t for a stone to fall from rest a distance of 2 meters. Alright, so now we have a third question, which says that the acceleration of free fall on the moon is 1/6 of that of Earth. On Earth, it takes a time t for a stone to fall from rest a distance of 2 meters. What is the time taken for a stone to fall from rest a distance of 2 meters on the moon? So we have an equation with us that can actually help us calculate. The equation is s equals half gt square, where g is the gravitational acceleration and t is the time, and s is displacement. So based on the question that I've been given, I can say that I have to relate g and t square with one another. And as these quantities are multiplied with one another, they are actually inversely proportional. Remember, whenever two quantities are multiplied with one another in an equation, these two quantities are inversely proportional to one another. So I can say that g is inversely proportional to t square. And if I'm going to remove the proportionality sign, I add a constant. And I know that whenever two quantities are inversely proportional, their product is constant. So gt square is equals to constant, which can be simplified and written as g1 t1 square equals g2 t2 square. Now, over here, I'm going to use this expression to find out my answer. g1 t1 square equals g2 t2 square. I'm going to denote moon as planet 1 and earth as planet 2. Question says that the acceleration of free fall on moon is 1/6 of that of earth. This means that g1 is 1/6 of g2, or g1 is g2 over 6. So I can write g2 over 6 over here. t1 square equals g2 t2 square. g2 and g2 cancel out. Then the question says that on earth it takes time small t for the stone to fall. So I can say T1 square equals 6 times of, in place of T2, I'm going to write simply T, because examiner said that it takes time T for the stone to fall on the earth. Then I'm going to take the root. It's going to be under root 6 T. So my answer is going to be C. Do you see how much use the direct and inverse proportionalities have whenever you're solving questions? Let's take another one. The kinetic energy of a particle is increased by a factor of 4. By what factor does its speed increase? All right. The relationship between kinetic energy and speed. It can be clearly seen that kinetic energy and velocity square or speed square are directly proportional to one another. How did I figure that out? Because they are in a ratio. Whenever two quantities are in a ratio, they are directly proportional to one another. So I know that kinetic energy is directly proportional to speed squared. Now, let's solve this. Kinetic energy was proportional to V squared, so I can say that when the kinetic energy was E, speed was V. I'm going to place a square, making sure that I don't make a mistake. They say kinetic energy is increased by 4 times. So if the new kinetic energy is 4 times the previous one, what's going to be the new speed? And you see, I always place the square on it because it was proportional to V squared. Now what I'm going to do is cross multiply. Whenever two quantities are directly proportional, the cross multiplication method is the best way out. So it's going to be E times x squared equals 4E times V squared. So x squared equals 4V squared, x equals 2V. So speed would have increased by 2 times. Your new speed is twice as the previous speed. It was a fairly easy question based on compared to those that we have solved before. But yes, it's something that we need to have a grip on. Let's try another one. A body traveling with a speed of 20 meters per second has kinetic energy Ek. If the speed of the body is increased to 80 meters per second, what is its new kinetic energy? Now, there are two ways to go about this question. The first way is an easier way. We right now already know that it's a relationship between kinetic energy and the speed. So we are well aware that kinetic energy is proportional to V squared. They said its speed was 20 and now it's 80. What's the new kinetic energy? So I can simply write it down as kinetic energy was Ek when the speed was 20. What's the new kinetic energy? It's going to be x if the speed is now 80. Then what you do is you cross multiply. So when you're going to cross multiply, it's going to be Ek times 80 squared equals x times 20 squared. And now you have to find out the value. 80 squared upon 20 squared equals x. If I simplify, it's going to be 80 squared upon 20 squared. Ek times 16. So your new kinetic energy is 16 times of your previous kinetic energy. The other way around to this question was like, you can still compare kinetic energy with speed squared, but you can say that the kinetic energy was Ek if the velocity was V. What will be the new kinetic energy if velocity is increased by 4 times? Because when you went from 20 to 80, you increased the speed by 4 times. So if I say if the velocity was V and now it's 4V, you can cross multiply it again and you'll be able to find out the right answer. It's going to be Ek times 16V square equal x into V square. Simplify, x is again 16 times of Ek. So you get the same answer in both ways. This one's easier. You just use the values that were given to you. So that's how you move about the questions with proportionalities. So now we have our final question, in which it says that the speed of a car increases from 10 to 15 and its kinetic energy increases by E1. Later, the speed of the car increases from 15 to 25 and its kinetic energy increases by E2. What is the ratio of E2 to E1? I have written an equation over here that is for the increase or the change of kinetic energy, that is half mv square minus u square, where delta Ek is the change of kinetic energy that I can right now say as increase, v is the final speed, and u is the initial speed. So if I begin my question over here, the ratio that I have to calculate is E2 over E1. So I can write half m v square minus u square. The velocities are going to be for case 2. And in the denominator, I can do the same thing, half m v square minus u square. And the velocities are going to be for case 1. Now I can cancel out the halves and the m's because it's going to be exactly the same. So E2 over E1 can be written as V2, it's 25 squared minus V1 is 15 squared upon, u square was 15 squared. Then over here, 15 squared minus 10 squared, because this was your initial speed for case 1 and this was your final speed for case 1. Similarly, this was your initial speed for case 2 and this was your final speed for case 2, where you said that the increase of kinetic energy was E2. So I placed on the velocities respectively, and all I have to do is now simplify. So this question, you didn't even require the idea of proportionalities. You simply had to put the value and get the answer to calculate your final answer. So the answer turns out to be 3.2. Hence, the value is C. So you see, my dear ones, how can the idea of proportionalities and a good grip on finding out the relationship between two variables in an equation can help you solve a very tricky question in just seconds. So I hope this technique will help you a lot. I will suggest you to practice more and more. Find some questions from your maths book or from a physics book and try to relate proportionality equations, like try to relate variables in different equations, try to find out if x increases, what will be the increase in y, if x decreases, what will be the decrease in y, and make sure that you have a good grip on that, because the better you are in this technique, the easier will be your MCQs. Most of the MCQs, should I say. So take care, guys. Allah Hafiz.